ठीक है ना। इस चैप्टर में सबसे इम्पोर्टेंट चीज जो होगी आपके पास वो गैसेस के बारे में डिस्कशन होगी। तो वी आर गोइंग टू स्क्रीन शेयर है, आप लोगों नहीं नजर आ रही?
सर आप स्क्रीन को वापस से शेयर कर दें, वो जगह पे स्टक हुई है सर।
चलें कोई बात नहीं, दोबारा से शेयर कर लेते हैं। देखें अब आ गई बच्चों?
जी अब सही है। यस
ठीक है, तो लेट्स स्टार्ट. So we are talking about kinetic theory of gases in today's class, and let's talk about this. So what is this? It is actually, you can say that it is the idea about the molecules of gases. This is actually the idea about the molecule of gases, that how they behave, right? How they behave. But so you know everything. We just talk about this in O levels as well. कि भाई gases के जो particles होते हैं वो एक दूसरे से दूर दूर होते हैं, वो random constant motion में होते हैं, और वो सारी चीजें हमने ओ लेवल्स में इसके बारे में बहुत पढ़ी हैं. तो उसी के बारे में हम स्टार्ट करें. The idea is actually about the molecule of gases is that they always in constant movement, and this is actually known as the kinetic theory of gases. You need to keep remember few assumptions about this, and these assumptions are, first of all, you need to keep about that gases are in constant motion. This is the kinetic theory of gases, and about this we have some assumptions. And what are these assumptions, bacho? These are very much important. You need to keep remember. The first one is that you need to keep remember the gases are made up of tiny particles. Gases are made up of tiny particles. Gases are made up of tiny particles. अभी जो tiny particles होते हैं इनको हम क्या बोलते हैं बच्चों? इनको हम molecules बोलते हैं. तो इसके मैं ब्रैकेट में molecules भी लिख रहा हूँ. Molecules, right? And they are always in a state of random and continuous motion. So you can say that they are always in a state of rapid, continuous, random motion. Right, Joe? This is the first assumption that you need to keep remember. Then the second one is you need to keep remember that the average kinetic energy of the particles is actually directly proportional to the temperature of a gas in Kelvin. You need to keep remember average kinetic energy of the particles is directly proportional to the temperature of gas in Kelvin, right? So average kinetic energy of particles is directly proportional to the temperature of gas, the temperature of gas in Kelvin, right? And then the third assumption that you need to keep remember is all collisions are perfectly elastic. You need to keep remember all collisions are perfectly elastic, right? And you need to remember there is no loss of kinetic energy. There is no loss of kinetic energy. This is the second, you can say that type, or the, you can say that the third wala point on is tarah se bhi keh sakte hain, there is no loss of kinetic energy. And then after this, the last one is collision between the molecules. Collision between the molecules. Collision between the molecules and the wall of the container. And the wall of the container. Gives rise to temperature. Give rise to pressure, sorry. Right, so these are the four assumptions about gases particle theory you need to keep remember. These are very, very important, right? These are very important, and they can ask an exam about any two of them and three of them multiple times. They ask in recent past papers, so you need to keep remember these points. These are pretty much important. And here we have two more points that you need to keep remember, that are point number 5 is the volume of molecule the volume of molecule, जो गैस के molecules होते हैं उनका जो वॉल्यूम होता है is what is negligible. कैसा होता है? negligible होता है, यानी कि बहुत कम होता है, बहुत कम होता है compared to the volume of the gas. अगर आप वॉल्यूम की बात करें किसकी? गैस की. compared to the volume of gas, volume of gas, right? And one more is, you need to keep remember, one more is attractive forces between particles are also negligible. You need to keep remember this one as well. Attractive forces between the particles are negligible. ये भी आपके पास क्या होती हैं? Negligible. All right, every one of you, these 6 points should be remembered by you all the time, because these points can be asked in exam randomly by you. So you need to keep remember all of them. All right, बच्चों.
Yes, sir.
Yes, sir.
चलें जी बेटे, कोई सवाल पूछ रहे हैं? नो? चलें नेक्स्ट. अब इस जो गैस था इसके बारे में हमें डिफरेंट साइंटिस्ट ने डिफरेंट इंफॉर्मेशंस दी, जिसमें से सबसे पहले हमारे पास कौन आए? बॉयल्स लॉ. सबसे पहले हमारे पास बॉयल्स लॉ है. बॉयल्स एक साइंटिस्ट है, उन्होंने जो है डिस्क्राइब किया गैस के बारे में कुछ, और वो क्या था, उन्होंने क्या डिस्क्राइब किया? वो क्या था भाई आपके पास? उसने ये बताया कि अगर आप किसी भी गैस के ऊपर प्रेशर लगाते हो, अगर आप किसी भी गैस के ऊपर प्रेशर लगाते हो, तो गैस के ऊपर प्रेशर लगाने से क्या होगा? गैस का वॉल्यूम जो है आपके पास क्या हो जाएगा? कम हो जाएगा. यानी कि प्रेशर बढ़ेगा, वॉल्यूम कम होगा. अगर आप प्रेशर कम करोगे तो वॉल्यूम बढ़ेगा. तो दे आर बोथ इनवर्सली प्रोपोर्शनल टू ईच अदर. सो उसने क्या बताया? उसने बताया द वॉल्यूम ऑफ अ गैस, the volume of a gas is inversely proportional to the exerted pressure. जो आप प्रेशर लगा रहे हैं उससे वॉल्यूम ऑफ गैस क्या होगा बच्चों? इनवर्सली प्रोपोर्शनल होगा if the temperature is constant. But you need to keep remember temperature should be constant for this. All right, bacho. So it would be like this. Remember, this is for suppose the volume, and if you are applying pressure, or for suppose it would be like this, inversely proportional to the pressure, and you need to keep remember that temperature should be constant for this. ऐसा होना चाहिए, constant होना चाहिए. So volume of any gas is always inversely proportional to the pressure applied. जो pressure आप उस पे apply करोगे उसमें हमेशा हमेशा inversely proportional होता है. अगर आप क्या कर दें, आप अगर इसमें is equals to साइन लगाएं तो proportionality साइन हट जाता है आपके पास, ठीक है ना, और आपके पास आ जाता है एक constant which is k right now, and it would be like this. तो ये हो गया आपके पास PV is equals to k. Right, so you can say that कि भाई अगर मैं प्रेशर चेंज करता हूँ, प्रेशर बढ़ाता हूँ या कम करता हूँ, वॉल्यूम बढ़ जाएगा या कम हो जाएगा, कांस्टेंट अपनी जगह रहेगा. आप कोई और प्रेशर लगाते हैं या कोई और वॉल्यूम हो जाएगा, बट कांस्टेंट स्टिल वो आपके पास सेम ही रहेगा. You can say that it is like P1 V1 is equals to P2 V2. This is what Boyle's law, and you need to keep remember the graph for this as well, which is very important. For suppose if you talk about volume versus 1 over pressure, talk about, because it is inversely proportional, so 1 over pressure, so the graph would be like this. All right, bachcho. All right, bachcho.
Yes, sir.
चलें तो आगे चलते हैं. नेक्स्ट इज हियर वी हैव चार्ल्स लॉ. इसके बाद एक और साइंटिस्ट थे जिनका नाम था चार्ल्स. उन्होंने भी एक आपके पास लॉ डिस्क्राइब किया, बट दिस टाइम ये लॉ जो था ये था विद रिस्पेक्ट ऑफ टेम्परेचर। अब उन्होंने जो है टेम्परेचर से रिलेट करके ग्राफ जो है आपने जो एक क्या कहते हैं आप उसको, इन्होंने लॉ बताया। और लॉ क्या था आपके पास, उन्होंने बताया द वॉल्यूम ऑफ द गैस। उन्होंने क्या बताया, द वॉल्यूम ऑफ अ गैस is directly proportional. The volume of the gas is directly proportional to the applied temperature. To the applied temperature. उन्होंने बोला अगर आप टेम्परेचर बढ़ाओगे तो आपके पास जो वॉल्यूम है किसी भी गैस का वो बढ़ जाएगा। अगर आप टेम्परेचर कम करोगे तो वॉल्यूम किसी भी गैस का कम हो जाएगा। बट इफ द प्रेशर इज कांस्टेंट, फॉर दिस प्रेशर शुड बी कांस्टेंट। देखिए कोई एक आपके पास वेरिएबल कांस्टेंट होगा तभी आप दूसरे का इफेक्ट निकाल सकते हैं, अदरवाइज आप नहीं निकाल सकते। तो इट वुड बी लाइक वॉल्यूम ऑफ द गैस इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर। आप टेम्परेचर बढ़ाते जाओगे वॉल्यूम बढ़ता जाएगा गैस का, जब तक आप उसको बढ़ाते रहोगे टेम्परेचर वो बढ़ता रहेगा, और जब आप टेम्परेचर कम करते रहोगे तो वॉल्यूम कम होता रहेगा। And when we remove the proportionality sign, so there will be the constant over here, and then the constant would be V over T. And again, it is V1 T1 is equals to V2 T2. If you change the temperature, so the volume would be changed, constant remains same. And what is the graph about this? If you talk about the graph again, same. This is volume versus temperature. So when you increase temperature, the volume would be increased. All right, बच्चों.
Yes, sir.
यस उसके बाद हमारे पास एक और साइंटिस्ट आए जिनका नाम क्या था, जिनका नाम था आपके पास एवोगाड्रो। ठीक है ना, तो एवोगाड्रो ने भी आपको एक लॉ दिया और उन्होंने बात की किसकी, नंबर ऑफ मोल्स की। उन्होंने बात की किसकी, नंबर ऑफ मोल्स की। उन्होंने बताया इक्वल वॉल्यूम ऑफ एनी आइडियल गैस कंटेन द सेम नंबर ऑफ मोल्स। उन्होंने क्या बताया, उन्होंने बताया इक्वल वॉल्यूम्स ऑफ any ideal gas, of any ideal gas contain the same number of moles, contain the same number of moles, right? If measure under the same condition and temperature, यानी कि if temperature and pressure is constant, we don't need to remove them. हमें इनको रिमूव नहीं करना वरना वॉल्यूम पे इफेक्ट हो जाएगा। ठीक है, इनको हमने चेंज नहीं करना। तो इसका मतलब ये हुआ कि V is directly proportional to the number of moles, and if you remove the proportionality sign, so it would be N, right? So this would be the mathematical equation for this law. All right, बच्चों.
Yes, sir.
Then here we have one more thing that you need to keep remember, which is very important: ideal gas equation. Ideal gas equation. According to Boyle's law, अगर आप Boyle's law की बात करें तो we know that volume is directly proportional to the inversely proportional to the pressure. According to Charles' law, we know that volume is directly proportional to the temperature. According to Avogadro law, we know that volume is directly proportional to the number of moles. So if you just combine all three equations, these are three different equations. If you combine all three equations, so it would be like somewhere volume is directly proportional to the number of moles and temperature and over volume. It would looks like this. Okay? If I sign P over here, so it would be somewhere like PV directly proportional to the ND. If I remove the proportionality sign, so there will be some constant, and this time the constant is R, which is journal gas equation constant, right? You can say that this is pressure. This is what? Pressure. The volume should be Newton meter square per meter square, right? This is volume. Volume should be in meter cube. This is should be in meter cube, right? And you can even use it in pascals. This is what? These are number of moles. These are number of moles. This is what? Universal. You can say that universal gas constant भी आप इसको बोल सकते हैं, universal gas constant. इसकी वैल्यू फिक्स होती है जो कि आपको याद करनी है. And this is temperature, which should be in Kelvin, which should be in केल्विन में होना चाहिए। अच्छा, इसमें कुछ कन्वर्जन्स हैं जो कि आपको लाजमी आनी चाहिए। वो कन्वर्जन्स क्या है भाई? वो कन्वर्जन्स ये हैं कि फॉर सपोज आपके पास अगर किलो पास्कल में प्रेशर हो तो आप उसको कैसे कन्वर्ट करेंगे? किलो पास्कल टू पास्कल में आप उसको कन्वर्ट करेंगे। सो इट इज ऑलवेज फॉर सपोज आपके पास 5 किलो पास्कल है तो आप इसको कैसे कन्वर्ट करेंगे पास्कल में? सो इट वुड बी 5 into 10 raised to the power 3 pascal, right? You just need to keep remember that 1000 pascals is equals to 1 kilopascal. You need to keep remember this. And then the very important one is all the time they gave us the volume in different conditions. For suppose if they give the volume in centimeter cube, so how can you convert centimeter cube into meter cube? So you need to keep remember that for suppose you have 25 centimeter cube volume, so it would be 25 10 raised to the power minus 6 meter cube. So you need to keep remember you need to attach 10 raised to the power minus 6, right? And if they gave you in decimeter cube, so simple as this, it would be meter cube. For suppose if you have 20 decimeter cube, so it would be 20 into 10 raised to the power minus 3 meter cube. So you can just arrange like this. And also the temperature, if they gave us the temperature in degrees Celsius, so you need to convert it into Kelvin. And what we need to do, for suppose they gave us 23 degrees Celsius, so we just need to add 273, and it would be for suppose 296 Kelvin. All right, bacho. So these are the basic conversions that you need to know about this general gas equation. They ask this question multiple time in exams. If you remember, मैंने कुछ questions भी share किए थे group में, तो बड़े काम के हो सकते हैं ये, तो आपको ये याद रखना है। ठीक है बच्चों?
जी सर।
एक और बात भी है इस इक्वेशन में जो कि आपको बड़ी इंपॉर्टेंटली याद रखनी है, और वो क्या है? फॉर सपोज वो आपसे एमआर पूछ ले या मास पूछ लेना। So we have PV is equals to nRT. So N is number of moles. So we can even break down the number of moles into mass over MR, right? And it would be RT. So we can even find out the MR or the mass of any substance. It would be mass RT over PV. You can find out the MR of any gas from this, and you can even find out the mass of any gas by PV MR over RT. So you can find out the mass of the gas. You can even find out the MR of any gas if the gas is unknown. Okay. And also we can even find out the density as well. For suppose it is PV is equals to mass over MR RT. So you can send MR over there and V over there. So it would be somewhere PMR over RT. It would be mass over volume, and the mass over volume is actually density. So you can even find out the density of any gas by this method as well. All right, bacho.
Yes, sir.
These are the few amendments that you can do in your equation to find different things. And also the very important thing you need to keep remember is the value of R. Value of R you need to keep remember, which is 8.31 joules per mole per Kelvin. This is the value of R that you need to keep remember. All right, bacho. Okay, so everyone, here we have one question for this. So let's start solving this question. Let's see if आप लोग इसको solve कर सकते हो या नहीं. So here we have one test for you, skill test for you. The question is what we have: the volume of a sample of ammonia. The volume of a sample of ammonia is measured at 60 degrees Celsius and a pressure of 103 kilopascal, and the pressure of 103 kilopascal, right? The volume measured is 5.37 10 raised to the power minus 3 meter. What is the mass of the sample of ammonia? You need to find out the mass. What is the mass of sample of ammonia? Okay, bacho. So let's start doing this. I hope you can do this and you can find out the right answer of this. Yeah. तो देखिए अभी ये वाला सवाल तो बड़ा सिंपल है, आप लोगों ने बड़े अच्छे से कर लिया है माशाल्लाह से. It is PV equals to nRT. N is number of moles, so you can write mass over mR. And as we need to find out what, as we need to find out mass, so it would be mass PVMR over RT, right? And pressure is already in kilopascal, so we need to convert it into pascals. We need to multiply with 1000, and the volume is already in meter cube, so we don't need to convert this, right? And the MR of ammonia is 17. We all know that. So हम उसको 17 कर लेते हैं. And over that, what we have R, which is constant, 8.314, and the temperature is 60 plus 273. Right. So when you solve this, so we will have an answer of 3.4 grams. Right, WS? ऐसी आया बच्चों?
जी सर यही है मेरा.
ठीक है, जबरदस्त. चलें अब हम एक और चीज देख लेते हैं यहाँ पर. वो जो सवाल उस दिन हमने ग्रुप पे शेयर किया था, उस सवाल को सॉल्व कर लेते हैं. जरा देखिए कि वो क्या सवाल था आपके पास. चलें, here it is a question. They are saying NCl3 decompose according to the equation. A seal container of volume 250 centimeter cube. Volume is actually 250 centimeter cube volume. You have 250 centimeter cube of volume and contain unreactive gas at a pressure of 1 10 raised to the 5 Pascal. Pressure is 1 10 raised to the power 5 Pascal, right? It's already given in the Pascal. 0.241 grams NCl3. 0.241 grams NCl3 का mass आपको दिया हुआ है. Mass of NCl3 is going to be decomposed. It's injected in a seal container. The seal container was heated to make NCl3 decompose fully and then cooled to 20 degrees Celsius. Right there, the temperature is 20 degrees Celsius. Calculate the final total pressure inside the seal container at 20 degrees Celsius after the NCl3 has fully decomposed. Yes, you need to find out what total pressure. What do you need to find out? Total pressure. Yes, बच्चों. You solve this. Try करें. कुछ नहीं करना आपने, सिर्फ आपने मोल्स निकालने और मोल्स निकालने के बाद आपने थोड़ा सा उन्होंने इस क्वेश्चन में आपको जो है परेशान करने की कोशिश की. अदरवाइज इतना मुश्किल नहीं है, आप इजीली कर सकते हैं. अच्छा, अगर आप चाहते हैं कि ये आपको पता चले कि ये कौन सा क्वेश्चन है तो आप ये लिख भी सकते हैं अपने पास. अगर आपके पास एयरलीज वगैरह हो तो आप उसमें कर सकते हैं. It is winter 20 and it is paper 2 question number 3 part D. ठीक है भाई, आप क्या करना है इसके अंदर, सबसे पहले तो आपने मोल्स निकालने हैं. ठीक है ना, आपने मोल्स किसके निकालने हैं? आपने मोल्स निकालने हैं NCl3. सबसे पहले आप फाइंड आउट कर लें मोल्स ऑफ NCl3. NCl3 के मोल्स कैसे निकालेंगे? It is mass already given to you divided by mR. The mass is you have 0.24, and what is the MR we have right now? We have 3 chlorines, so 3 chlorines would be 35.5 into 3. It would be somewhere आपके पास कितना हो जाएगा बच्चों? ये हो जाएगा 106.5. ठीक है ना, उसके अंदर आप 14 ऐड करेंगे तो it would be 120.5. तो ये हो गया 120.5. इन दोनों को डिवाइड कराया, चेक करें कितने मोल्स आ रहे हैं बच्चों. I think it would be 0.002, right or not? कितने आ रहे हैं बच्चों मोल्स?
यस सर. जी इतने ही आ रहे हैं.
ठीक है, उसके बाद आप रिलेशन लगा लें. जरा रिलेशन लगाएं किससे? आप टोटल गैस के वॉल्यूम से रिलेशन लगाने के लिए आपको टोटल गैस के मोल्स भी चाहिए होंगे. तो here we have 2 moles of the NCl3. NCl3 के moles कितने हैं हमारे पास initially जो decompose हो रहे हैं 2, and the total moles of gases. Total moles कितने आपके पास बन रहे हैं? Total mole gases के कितने बन रहे हैं बच्चों? 3 + 1 4 बन रहे हैं. तो अगर 4 सपोज आपके पास NCl3 के 0.002 moles होते हैं तो ये कितना बनता? Just need to cross multiply and you will see this कि भाई इसका आंसर आपके पास आएगा x is equals to 0.004 moles. तो ये हो गया आपके पास टोटल मोल्स बच्चों कि जो आपके पास गैस के बनेंगे. दिस इज द टोटल मोल्स. दिस इज द टोटल मोल्स ऑफ व्हाट, जो कि आपके पास आ रहे हैं किसके? गैसेस के. हमारे पास गैसेस के आ गए हैं मोल्स. ऑलराइट बच्चों, अब हम कर लेंगे वो वाला फॉर्मूला अप्लाई व्हिच इज एक्चुअली PV is equals to NR. ठीक है ना. अब P क्या है हमारे पास? प्रेशर इज ऑलरेडी प्रेशर. एक्चुअली वी नीड टू फाइंड आउट प्रेशर. तो हमें फाइंड आउट करना है प्रेशर. हमें फाइंड आउट करना है तो फॉर्मूला हो गया nRT/V. ठीक है ना भाई. n कितने आ गया हमारे पास? n आ गया हमारे पास 0.004. ठीक है. और r की वैल्यू इज कांस्टेंट व्हिच इज 8.31. ठीक है. 20 डिग्री सेल्सियस आपके पास टेंपरेचर है तो इसके अंदर आप 273 ऐड कर दें तो इट वुड बी 293 केल्विन. एंड वी नो दैट हमें केल्विन में यूज करना होता है तो इट वुड बी 293 केल्विन. ठीक है. साथ साथ आपके पास वॉल्यूम सेंटीमीटर क्यूब में तो आप देख सकते हैं 10⁻⁶ लिखेंगे तो ये मीटर क्यूब में कन्वर्ट हो जाएगा. तो इसका मतलब ये 250 10⁻⁻³ आपके पास आ गया वॉल्यूम. तो जरा देखिए बच्चों प्रेशर कितना आया आपके पास? मेरे ख्याल से इसका आंसर आपके पास आना चाहिए प्रेशर शुड बी 3.9 10⁻⁴. कितना आ रहा है बच्चों? पास्कल्स. यही प्रेशर आ रहा है आप लोगों के पास? ठीक है. उसके बाद आप लोगों ने टोटल प्रेशर एक्चुअली आप लोगों ने निकालना था इसका. तो टोटल प्रेशर आपका क्या होगा? एक प्रेशर आपके पास ऑलरेडी मौजूद है और दूसरा प्रेशर आपने निकाल लिया है. एक ऑलरेडी प्रेशर क्या था आपके पास? 1 × 10⁵ था मेरे ख्याल से ना. वहाँ सही कुछ था. और दूसरा आपके पास आ गया 3.9 10⁻⁴. इन दोनों का आप सम कर लें. आपके पास जो आंसर आएगा इट वुड बी द टोटल प्रेशर of this. और इसका आंसर कितना आ रहा है मेरे पास? इसका आंसर मेरे पास आ रहा है 1.39 10⁵ पास्कल. This is the total pressure. और बच्चों this is the question. जी बेटे पूछिए.
सर जो आपने इक्वेशन बनाई है PV = nRT वाली, सर वहां पर आपने वॉल्यूम का एक्सपोनेंशियल -6 आएगा -3 आएगा?
बेटा अगर आपको देखते हैं ये वाला MCQ आप कैसे सॉल्व कर सकते हैं. देखिए भाई आपको किस तरह से सॉल्व कर सकते हैं. चलो ये बच्चों the question is here. They are saying that 2 glass vessels M and N. ये 2 ग्लास वेसल्स हैं आपके पास. एक आपके पास M है और एक आपके पास क्या है? N है. This M and this is N you have, right? So we have 2 glass vessels, okay, and they both are connected, but they are connected by a closed vessel. This is closed right now. This is closed. They are saying M contain helium. M contain helium at 20 degree Celsius temperature and at a pressure of 1/10⁵ cube, 10⁵ pascals pressure. And then they are saying N has been evacuated. आप वो खुलना शुरू हुआ है and has 3 times. They are saying 3 times the volume of M. In an experiment, the valve is open and the temperature of the whole system is going to be 100. They're asking about the final pressure of the system. They're asking about the final pressure of the system. So we know that. What is the formula? We know that PV is equals to nRT. This is what? This is, you can say that this is the formula that we know already, right? And over here, the pressure is changing, the volume is changing, and the temperature is changing, but the number of moles and the Avogadro and the general gas equation constant is remain same, right? So we can write this in this way and these two constant in this way. So we know that we are just talking about right now the pressure of M initially, and then the volume of M, and then the temperature of M, right? It's actually equal to the NR, right? You can even say that the pressure of the overall system they're asking for, and the volume of overall system they gave us, and the temperature of overall system they gave us, and they are also equal to NR. When they both are equal to NR, so we can equate them. So it would be PM VM over TM is equals to PS VS over TS. And what is the pressure of M? You can see this. It is 110 raised to the power 110 raised to the power 5. It is 110 raised to the power 5 Pascal. This is simple. And they gave us that the volume is thrice. It means we are just considering the volume of this as V. And then you can see this, the temperature they gave us is 20 degrees Celsius. 20 plus 273 will give you 293 Kelvin. So it would be 293 Kelvin. And over here, the pressure we need to find out. And the volume is thrice, 3 times, right? And the volume is 3 times of M, mean guna zyada hai. Or pressure, temperature is 100. So 100 plus 273, it would be 373 Kelvin. So now we can solve this, equate this and calculate the answer of this. Let's see what is the answer, bacho. Yes, bacho, can you solve this now? The answer is, you can find out that pressure we need to find out. It is 110 raised to the power 5 into volume into 373 over, it is 3V into 293. The simple as this, you can cut V by V. The remaining one you can solve and find out the total pressure in pascals. So let's see what is the total pressure. We have, here is calculator, here it is. It is 110 raised to the power 5 into 373 over 3 into 293. So it is somewhere 4.24 10 raised to the power 4. So it would be B. All right, bacho.
Yes, sir.
Yes, sir.
So this is what you need to understand about this formula.